will introduce the German's COVID data platform and the HiGHmed project. And Antje will show an application on top of that platform for smart infection control and the tracing of COVID, Antje Wulff. Afterwards, there's a short Q&A, and then we'll have the openEHR e-learning environment. I think it's okay if you have questions to ask them in the chat right away, so that you can so that we can gather the questions and ask them at the end of the presentation, or maybe if it's something needs to be clarified, we can ask them in between as well. So what is openEHR the Netherlands? We are a foundation, and we're here in the Netherlands to share knowledge on openEHR, and also to build some of the integrations for Dutch healthcare. And for that, we're now working together with a couple of people on translating the zips into archetypes and templates that are used within the openEHR platform. Quick overview of openEHR for people who don't know what is openEHR. openEHR is an open standard specification for capturing electronic health data, CDRs, and it should be vendor neutral, vendor independent, and recording clinical data for the lifetime of the patients. The idea is that, like we have for PACS systems and documents, we now have standardized shared repositories, so that you can put any application on top of a PACS system and use it. We should have the same thing for structured data, and that's what openEHR is aiming. We want to have an open platform where any application that is compliant with openEHR can be put on top of any openEHR backend. So openEHR technology, this is the set of specifications that we have within openEHR. It's a very broad reference model with all kinds of classes that you would need on a technical level, like what was the time that a certain clinical document came in, for instance, a MRI or some other things. A lot of things there for versioning as well. And then we have Archetype. Those are the building blocks. In the Netherlands, we would call them probably zips. Those are the small clinical building blocks, like a blood group or a blood pressure, these kind of things. And on top of that, we make templates for the use cases to combine the archetypes. And if you have a set of archetypes and a template, we store them in a database, and we can also query them again, which is very helpful. On top of all of this are open APIs that can be used to get the data out and also store the data from any application that supports that. So that's openEHR in a nutshell. openEHR is a set of information model specifications and an open API specification, and then you have a lot of vendors implementing openEHR. And today we have with Birger, they're working also in that project on an open source version. We have already one ATHERsys and now open. Oh my God, Birger, you have to help me out.
So it's the Airbase.
Airbase, yeah, thanks. Sorry about that. Which is now, well, it's looking very good. So that's it for my introduction. It's a very brief introduction. We can talk a lot more about on openEHR, but there are some resources out there to look at that. This is also the final one for this year. Next year, we're already planning to be back with another set of webinars after New Year. So that's it for me. I'd like Birger to quickly take off and talk to us about the HiMAT project, if you will, Birger.
Yeah, thanks a lot. I think I need some rights to share my screen.
Yeah, I'll stop sharing. Then you should be able to share.
Yeah, looks good. All right, can you see my slides? Oh, thanks a lot.
Yes, yes, we can. Sorry.
Very good. All right, so I think it's going to be a dense presentation, so let's get started. I am going to talk about the HiMAT project and also our activities around a COVID-19 platform for Germany, all based on open standards. So the background in HiMAT is that our government set up a funding scheme called Medical Informatics Initiative, which serves the goal to use the data that's produced inside the healthcare system and make this available for research, because as of now, the data inside electronic health records cannot be easily used for this purpose. And by doing so, we hope that we can lay a foundation for a concept which is called the learning healthcare system, so that we can have the knowledge that is created by using this data at the bedside, but at the same time use the EHR data for obtaining and gathering new knowledge, creating new knowledge. So the basic goal is we want to have a national infrastructure that enables us to use data from hospitals for other purposes. So the HiMAT consortium consists of around 1/4 of all German university hospitals. On the right-hand side, you see some of the partners. We have University of Heidelberg, Charité, and Antje and myself are from Hannover Medical School. So we started in 2018, and we got funding of around 50 million euros until 2022. And to show the added value created by the approach and the initiative, we implement use cases in the fields of oncology, cardiology, and infection control. And Antje will show later our work on infection control in greater detail. So yeah, building a secondary use network. So what's the problem? How hard can this be? So we can take a look at the German healthcare landscape. So we have GP software, and we have the secondary care sector with the hospitals and hospital information systems, pharmacies, care homes, labs, and of course the patients starting themselves to get engaged in collecting data. So we are now focusing on our hospital information systems, and this is one example of an overview view from Hannover Medical School. In the middle, you can't read it, but it's our communication server, which tries to tie all stuff together. And we can take a deeper look on the example of the ICU systems. So at the moment, we have 3 running systems. 2 are actively used for the treatment of patients and documentation. And so this is a typical example. So it's not one of our systems, but it's a typical system you find in the ICU. So we have a timeline and lots of different parameters. So the information density is quite high, I would say. And the problem is systems have databases, and every system has its own database. So this is one database that you need to understand in order to obtain the data. The problem is that in healthcare, the database schema is not everything that you need to know, but there's also a thing called an information model, which can reside inside the database. So it's more something that's existing in the raws. And on the left-hand side, you see an example from Hannover Medical School, where you see multiple definitions of these clinical parameters and information models inside the database. So these all have a particular code, and they have different data types. And when you want to build a data set, for example, you have a score with multiple items, this is all system specific. So you need to know the database structure, but also what's inside the tables. So then to obtain the data and use for research, you need to know the system quite well and define custom-made SQL queries. So potentially with lots of joins. And you will find some concepts are all over the hospital. So if you are interested in the blood pressure of a patient, you will find it in the emergency department, in the operations theater, on the wards. So it's basically everywhere. And this is only the managed systems. So in the university hospitals, we have hundreds of systems that have been introduced because the official IT systems are not sufficient to store the cutting edge research data or care data inside a university hospital. So there's lots of parallel systems around that are not well managed. So it's basically access tables and access databases, some FileMaker as well. So and if you want to use the data in a research network, you have the problem not once that you could solve maybe in a data warehouse, but many times. And yeah, this is where the problems are starting. And so our conclusion when we started was that our hospital information systems are not really suited to fulfill the requirements of the medical informatics initiative. So we thought, okay, what do we have to change in order to be successful? And then we came up with the concept of an open platform. So what we introduced as part of HiMAT is a scalable platform according to the FAIR principles. So data is findable, accessible, interoperable, and reusable. And distribute this platform across all the different sites that we want to connect. So we are basically enhancing the capabilities of the hospital information systems to deal with the variety of data, but also the interoperability challenges. So what we're basically doing, we are using several standards. You can see this at the bottom. So for example, we define a master patient index, and the interfaces are required to use something from IHE, which is called PICS-PDQ. Then we have terminology services, in which we agree to use FHIR terminology service. So for example, for HiMAT, we have an Onto server license, which serves us with SNOMED and LOIN codes and ICD. We have things like provider registry and patient content management, which is also then managed using IHE standards. But then for the structured data, we are agreeing that we would like to use openEHR. Then, of course, we need some standards and synchronization for security, monitoring of the system. And then on top, based on the interfaces, we are building different kinds of applications. So we have applications for cross-enterprise research. We have patient-facing applications that at the moment, but this is what we would like to do in the future. And then we have also clinical applications inside the care domain of hospital. So including smart infection control system and our virtual oncology center, which is a tumor board. So we place this architecture inside each participating hospital and put a thin layer on top. So with the so-called data sharing framework, which orchestrates the processes, because we also want to be able to ask for data from different hospitals. So there needs to be a shared authentication service as well. And then we have terminology service, metadata management, knowledge service, ID management, and so on. So for the information governance, we are using our own clinical knowledge manager. So this is something that we set up for the German domain. And we did some workshops, did the onboarding. And I think this was quite successful, I have to say, also thanks to Antje, who led this effort. So at the moment, we have over 200 archetypes and 70 templates, which are used in our use cases. And we have around 140 users, which are registered in the platform. And I think at the moment, it's around 100 active users. And you can say it's around 50 or 40 users, unique users per month. So it's a bit changing. But we are growing again because we have now some more projects that are related to HiMAT. So that's quite a good uptake. And we have been also successful to adopt many international archetypes. So as you can see here, we have 75% approximately from the international CKM and only do 1/4 ourselves. So and this has been really successful. So what we also do, because we are using openEHR, is building applications. So for example, for our cardiology use case, we needed an application at Hannover Medical School to enhance the process in patient admission and do the patient anamnesis. And so we built an iPad application. So this is based on the beta forms from the beta platform. And this is so-called this starting screen. So you can select a patient by their ID, or you can scan a barcode, so which has the encounter ID and the patient identifier. And then you can directly jump into an openEHR form, enter all the data, and if it's in accordance with our data models that we agreed in the network, this data can be queried basically right away or used right away because it's recorded at the point of care in a semantic format following a standard. So there's a second way because, of course, there's also existing systems, and sometimes a ward is using our SAP HGiHmed system. So in this case, we are building openEHR templates. So you see one template for the oncology use case with some scores and the overall state of the patient. And then this is being implemented in our SAP system. So this is a direct implementation. And then we are doing an integration job using our intersystems ensemble communication server, so that the data is entered in SAP, but then directly being put into the openEHR repository and being made available for our applications as well. So you can think about it this way. So our care domain on the left-hand side with the different systems, including HiGHmed, then it's going into our communication server. And then there's the openEHR repository with the different applications. So this is the architecture for one site for Hanover Medical School. Yeah, this is what we do internally for the care provision domain. So then the idea is that because we are using the same semantic standards in all the different places and can enhance the data model and the applications quite quickly, that we can use the Archetype query language to distribute the queries in the network, or that we are able to share applications or analytics scripts in the network and can execute them locally. So there's a mixture of, okay, we are doing distributed queries and we're doing local queries. So this is where we are at the moment. So in December, we will have, I think, the first horizontal implementation so that we can have the exchange of the queries in the network. But yeah, we were not as fast as we intended because Corona happened. So all our plans had to change quite a bit this year. And so we refocused our activities around March this year and spent our time a bit differently. So COVID-19 came along and brought some new challenges, a bit similar to what we actually want to achieve in HiMAT. So this was basically a good fit. So we have this new disease and we want to swiftly generate new knowledge. And we want to use the data from electronic health records from the different organizations for this purpose. And we have the same problem, the data is not easily accessible, not yet. So on the other hand, we have also the problem here as well, that when we have new guidelines or new applications that can help at the point of care, it's not something that you can easily deploy in the network or in multiple university hospitals, because when there are not yet the semantic standards in place, it's quite difficult. So the Federal Ministry for Education and Research set up another funding scheme called the Network University Medicine and provided 150 million euros for COVID-19 related projects. So all the consortia of the medical informatics initiatives, including HiMAT, joined up and did a joint proposal and suggested to implement an open platform approach, somewhat centralized approach that should collect all the COVID-19 data from 36 university hospitals. So the design philosophy, so it's some quotes from the proposal to achieve the goals of the initiative and the network, University of Medicine, a traditional data registry approach is not sufficient because what we want to have is the real-time monitoring of cases that are treated inside the hospital. So we want to really know what's going on at the moment and to make the clinical guidelines available at the point of care. And then we should also have a new mechanism so that we can gather the long-term outcome data for the patient. So what happens after a patient is discharged from hospital? So what is the state of the patient after 6 months or maybe 12 months? Yeah? So patient-reported outcome can also play a role. So this is the high-level architecture of what we try to do. So we have our local hospitals on the left-hand side and the national platform sitting in the middle. And these are the, let's say, main use cases for the central platform. So we want to integrate and store COVID-19 data from the university hospitals in accordance with a standardized national data set called GECKO. And the main feature is a researcher portal, so that researchers from these organizations or beyond can apply for accessing this data collection. So in this sense, it's working like a clinical registry. So we are using different tools to allow the building of queries and applying for a study. And it should also become possible to execute further queries so that the data from the centralized platform can be mixed with some data from the local sites, so which data is not included in this Gecko data set. And of course, we need to ensure that the patient consent is respected. Yep, and of course, the data also needs to be forwarded to other projects that might be interested in the data. So there might be other registries or data collections. So, and also a nice cornerstone is that all the components are meant to be published under an open source license, which I think is pretty cool. So what we did is, so this is not let's say, a production version, but a proof of concept that we did to apply for the money. So this is all built on openEHR, what you see here. So we have an overview of the number of patients and the number of data inside the platform. And on the right-hand side, you can see the different kind of data to represent COVID-19 related clinical data. So you have some demographics, vital signs, diagnoses, and some scores from the ICU, and also then lab values. And then some, let's say, figures to give a quick overview. But then we can go quickly to our patient level. So we can use openEHR to define these queries in a model-based way. So Wouter mentioned this in the beginning. So this is the Archetype query language. And in this example, we are searching for a patient with a CRP lab value above 50. So we're creating the query, and then we can select from the patient set on the right-hand side. And yeah, to demonstrate how the data is residing in the platform, we made this dashboard view so that you can dive into the data and see the data, basically the patient record of a patient with data are stored in the platform. So you can see a plot for the vital signs and for the lab values. And we could also have capabilities to store more granular data. So for example, for the SOFA score, you can see some details. There's a form in the background, and then you can see the particular values that are part of this score. And we also integrated a third-party tool, so that would allow you at the runtime to add new forms, so that you could also enter data directly. So this could be rolled out at the local sites to support data capture when extracting from systems is not possible. And I think this will happen in reality, that some data can be automatically put into the platform because it's already structured, but sometimes it's something that you have to do manually by a data manager. Yeah, so you can enter the data from where you are. So this would normally then be taken from the session. As mentioned, it's a proof of concept. And then this is stored in the platform and can be seen again in the patient timeline. So besides the research capabilities, we want to have some transactional capabilities for, as mentioned, things like patient-reported outcome or symptom diaries. And so we also have a transactional component in the platform, which should allow to deploy and develop new applications. So it has identifiable patient data, and we are using smart on-fire interfaces and a file demographic service, but store the data in openEHR and use our software development kit from our air-based implementation to develop new applications. So this could be then different services for the citizens. For example, there's a self-assessment tool called CAF-App, which will tell you, should I go to the emergency department, to my GP, or better stay at home? And if the patient has given his or her consent, the data could also be then added to our research repository, which is physically and logically separated from this EHR system. So one quick example, so we have a separate application using Angular, which is using the software development kit. And this is an application that could be used for patient self-assessment for the symptoms, for their body temperature. if they have been traveling to certain areas with a high risk. And then they could give an overall rating of their well-being. And then the data could be directly put also in the research platform if the content is available. So we are using interoperable models, so it can be directly integrated. So to feed the platform and also to provide some local services, there are so-called local nodes of the COVID-19 platform. So we are using locally a Firestore to integrate the data and make them ready to be sent to the platform. And there will also be Docker images or virtual machines, which will provide analytics tools like an I2B2 clinical data warehouse with standardized integration scripts that will help to have a quick analysis of some important factors. And we will also have our smart infection control system as a single application component, which will also be delivered as part of the decentral platform node. So some words about the data that we are collecting. So the colleagues from the Charité in Berlin created the German Corona consensus dataset called GECKO, and it contains around 84 high-value data types, so demographics, symptoms, diagnosis, risk factors. And the goal is to get some standardization into the different research projects around COVID-19 in Germany, but also for the university hospitals to define a set of data that needs to be delivered for the centralized platform. So it's using FHIR profiles and these terminologies like SNOMED, LOINC, ICD-10. And it's also reusing some of the definitions from the Medical Informatics Initiative. So they want to leverage the work that has been done before by the Medical Informatics Initiative to quickly provide this data. So if you want to take a look, there's the link. And so what we do with the FHIR data being sent from the local hospitals, we have a component based on Apache Camel, which is called the FHIR Bridge. So you see here an empty patient record inside the central research platform. And here you see a Postman, a REST client, which has some FHIR resources, for example, for the body temperature. So we can have a batch job and then send all the different FHIR resources to our FHIR bridge. And then the data is automatically being validated and transformed into the openEHR format. And so it can be easily used by this application to populate the UI so that researchers can directly use the data by visual components or by creating AQL queries for their analytics purposes. So to summarize, the platform is hopefully in production ready by the end of March. So we are working quite hard every day to make it work. So in our team for the centralized platform, we are working with around 40 people on this thing. What's, as mentioned, is pretty cool is that all the components are going to be available on an open source license. So if there's an interest from other countries, I think there's a great openness to share our results. And as we are building on an open platform, we try to do an iterative approach. So we start with some minimal stuff, so the basic data collection and analytics, but we can enhance as we go and build new applications based on our open APIs. As mentioned, it's challenging, but we have some good preliminary work from the Medical Informatics Initiative, and this has really been a big asset so far, so that we didn't have to start at zero. And I think what really helped us is the use of open standards, because we are doing most things in a model-based way. And for many things, we don't have to do coding. We're just configuring and using openEHR templates, for example. And the components based upon this are quite generic. So even if the COVID-19 use case is over, it's easy to adapt thanks to openEHR and to FHIR to new use cases that can be addressed by using such a platform. So thanks a lot. So please visit our website if you want to have more information or send me an email. And then I would like to hand over to Antje to give some more details about the smart infection control system, which is part of HiMAT and the COVID-19 platform as one of the key applications.
Thank you very much. So I think I will take over now, and I will share my screen. So, can you see my screen? Okay. So I'm very happy to be able to present to you the adaptation of our smart infection control system to trace now SARS-CoV-2 infections within hospitals. And to start with, I want to go back to HiMAT. As Birger presented, we defined 3 use cases to demonstrate the potentials of our HiMAT platform. One from oncology, one from cardiology, and the most important one for this presentation now is infection control. In infection control, all is about early warning and cluster analysis to support the algorithmic detection of pathogen clusters. The background is that the spread of multi-drug resistant organisms, MDROs, is a global healthcare challenge. And especially nosocomial outbreaks caused by MDROs are important contributors to this threat. So we thought automated algorithm-based and open source applications might enable a rapid outbreak detection and therefore can be essential tools to address this issue. Of course, we also need some harmonization and integration of the heterogeneous data sets because they are stored in various primary source systems and we need to bring them together, especially when we want to make the applications reusable across institutions as aspired in the HiGHmed project. So we decided to design a smart infection control system. The smart infection control systems mix should be able of visualizing patient data, movement data, and laboratory data, and especially in HiMAT, it's all about microbiology findings on pathogens. So, for example, MDROs. These mix also should be able of detecting pathogens, but also pathogen clusters, and in the end, of course, also outbreaks. And altogether, it should deliver support in the automatic surveillance of pathogens. Of course, we also want to use the cross-institutional data sharing framework Birger presented, and we also want to use some machine learning to be able to learn more about important crossing points of patients and also the origin of infections, because it's very difficult to find them sometimes. This mix is based on the HiMAT platform, and all required data sets are modeled as openEHR archetypes and templates, and they are also enriched with international terminologies such as NOMID. And all these data sets are integrated into the local medical data integration centers at each participating institution. And these MEDIC frameworks or architectures are fully based on the HiMAT platform approach Birger presented. We decided to design SMICs by designing separated building blocks, and we have different building blocks. The most important one is the AQL interface. We designed an AQL interface to the data platform to get the data from the openEHR repository. And of course, we also have filtering options to be able to adapt the queries, especially on specific pathogens or wards or patients. Then we have the interface for the external data exchange. However, this is not implemented yet because at the moment we don't really have a use case in infection control for this, and the local implementation, is the primary goal of our use case. Then one very important component is the visualization component. This is something like a patient timeline, and you will see this later. Then another very important thing is the algorithmic, and we defined 2 components for this to be able to detect outbreaks and clusters. We have defined a component called live monitoring and a component called machine learning module. And in the end, we also have some additional components about statistics and reporting. And these are some simple calculations or functions such as exports, etc. The data models this mix is based on are mostly three categories. One is for microbiology, for representing the microbiology report. Then we have the administrative patient data, such as admission and discharge data. And of course, this is not enough to track patients. So we needed new models for capturing the patient locations during the hospital stay. And we designed archetypes and templates for this, but we reused a lot of the international archetypes. You can find all of our models in our CKM instance in the project Infection Control, and this is open, so you can just have a look at it. On the right side, you see the hierarchy structure of our microbiology report template, and I want to quickly show this to you because it was very complex to model this thing. And however, we were able to reuse a lot of the laboratory test result archetypes for this, but especially when it comes to the antibiograms, it took a lot of review rounds, I think about 150 review rounds to consent this template. Of course, we also need some terminologies. As I said in the beginning, we mostly use SNOMED, but also LOIN codes, especially for the laboratory values. And we also have some local value sets. Of course, this is kind of a limitation of our application. However, this really was important because we are not able of standardizing all local value sets for example, all microbiology pathogens. We needed to focus on a small set we want to start with, and then we started with the ones we focused on in our use case, and these were the MDROs. All of our value sets and terminologies are stored in the terminology server, Onto server. However, you can't see the things in the CKM instance right now because the CKM and the Onto server are not yet connected, but we're working on this. However, you can have a look at our value sets and terminology bindings when you go to our resource center in the CKM Infection Control project. On the right side, you see some examples. For example, the specimen. Because we focused the microbiology findings, we said that especially the blood culture are important, the aerobic and anaerobic, and the SWAP. And all other values are allowed as free text for now, because it took so much time to standardize even these things, these few things. Which was very interesting about microbiology reports is the usage of the laboratory test analyte item. We discussed it a lot, especially also with Heather or Celia from the international community. And in this context, we used this analyte as a thing for capturing the absence or the presence of anything, because in microbiology, you in most cases you don't have a specific order request. It is just that if you want to look for anything in this specimen, so the analyte is the presence or the absence, and the identified pathogen is then the result. In other laboratory results, it's a concrete quantitative number, for example, but we don't have it here. But it works very fine with our local data, so I think it's the way to go. Then for the algorithms, I said we have two components. The one component is about a more statistical based way of detecting outbreaks. You can see it on the left side. It's made from a colleague from the Robert Koch Institute in Germany. And it calculates the normal value of infections on, for example, a specific ward or in the hospital or for some specific patients. And yeah, in some cases it alerts when the number is higher than the normal value. On the right side, you see the machine learning component, and we decided to start with searching for people which should be tested but haven't been tested yet. And also to be able to reduce the number of unnecessary tests. And therefore, the colleagues from the NEC laboratories in Heidelberg, Germany, designed a Python algorithm for that. However, these two algorithms are not yet fully implemented in this mix, but I think they will be in the beginning of the next year. Some things on the technical background, however, my colleague Pascal Biermann, who is not here today, will be happy to answer all the really technical questions because he's the technical lead of this. And I can tell you the most important thing is that we have an HGiHmed interface, and it's simply a client connection to the openEHR service. And we get JSON responses of the HGiHmed queries, and we send the JSON responses to the visualization module or to the algorithmic modules. This mix is in web app, so it's a web application with .NET Core, and the whole mix should be Apache conform. So, however, in some modules we still we're still reviewing the licensing, and yeah, there will be some discussions about that. The visualization module is a Node JavaScript application or module, and it's fully integrated into this Mix web app. We have a prototype which is available, and it's deliverable with Docker Compose. However, of course, it's a prototype for now, and there are some local data transformations in that. So we're right now working on getting a full version 1, hopefully available also in the next month. Here's a quick view on the visualization component. However, I will skip that for now, but come back to this later because we will need a bit more time to look into the details. So this is all about HiMAT infection control use case, and I thought this would be enough. But then, of course, Corona happened, and it is quite straightforward that we might be able to use this application to trace COVID and Corona infections. And this is, of course, what we started to do. And we started to implement it COVID mix, especially in the first case for Codex. Codex is the platform project Birger presented. And the focus now is to adapt mix to trace biology findings. So, and the focus, of course, is on the SARS-CoV-2 infections, cloud clusters and outbreaks. Therefore, we of course need new data models, for example, the biology report, but it was very good that these are not as complex as the microbiology ones. This was very good. And we already modeled some things on PCR and RNA tests and antigen tests and antibodies. However, this was all done in the fast track modeling, and we will need more review rounds to really condense them. In HiMAT, we use the openEHR based platform by Marant. And for the approach in Codex, we use an open approach. So now our SMICS needs to be based on Airbase, and we need some adaptation for that. However, the AQLs should work as they are. However, there will be new AQLs because now we have biology reports. The COVID mix will be made available as a central application in the central component of the Codex platform. And yeah, of course, we also will need some modifications of the algorithms, but we think that we will not need completely new algorithms because the tracking approach are quite similar. The good thing is we can reuse the same architecture and we can reuse the visualization components. So the adaptations are mainly in the data models and the actual interface. And yeah, this is the second great challenge for us. And of course, we have a third one. And the third one is another project, which is called BFAST. It's more about a broad surveillance framework and optimizing surveillance strategies in Germany. And it's another project of the Netzwerk Universitätsmedizin initiative. And the COVIDs-Mix for BFAST is mainly the same COVIDs-Mix as for Codex. However, we want to include a proof of concept for syndromic surveillance. So we additionally focusing on symptoms. And we also have so many other ideas on integrating diagnosis, intensive care therapies, maybe data on employees, and however, these will be things for the future. The platform will be the same as in Codex, so Airbase, and however, within BFAST, the COVIDs-Mix will be rolled out to all participating centers, even locally. So there will be a central and a decentral component of the COVIDs-Mix.
Antje, you have about a minute left in your time. Is that enough?
Yeah. So, and we have some architecture and some visualization, which is all the same, but of course we need some modifications. So I want to have a look at the visualization in the end. So this is the visualization. We have a YouTube video, so you can just look at with having more time. And to go quick through this, we can discuss it later. We have a patient timeline where you can see the patient movements, and the blocks, the red and blue ones, are the infections. So the virology findings. And then you can have at a quick view whether patients were together or not. We have some epidemiology curves, the cumulative ones, and also one for getting new cases. And the two very interesting things is that we have contact networks, where we have the bubbles as patients who are infected or not, and you can see whether they had contact or not. And not as intuitive one, but it's very good. Here you can trace back patients to the first time they had contact. For example, you can see here that a blue one had contact with a red one, and it gets red later. So this might be the origin of getting the infection in the hospital. And this is all about COVIDs-Mix and COVIDs-Mix for Codex, for BFAST, and for HiMAT. Thank you.
Thank you, Antje, for this for your presentation. Thank you, Birger. I think we go right into the questions because there are a lot of questions, and the first ones are for Birger, I think. So let's get started. I would say. Ruud Bongers from the UMCU. He asked, would you say the focus of the platform is on healthcare or research? And is the data real-time enough available for diagnostics and treatment purposes?
Okay,
Birger.
First answer, research or healthcare? Yes, so it's both. So this is really what we, let's say, aim for, because you can build a normal data warehouse, but I think this is not sufficient anymore if you want to really use the data intelligently. So we really made sure that the platform, as for example in Hanover, 2 instances. One is optimized for care provision, one is optimized for the research. So it's all about also regarding the synchronization of the data and what kind of data regarding the data quality you allow to flow into this. So in a research environment, you might be a bit more loose and say, look, I also introduced some data from a tumor registry or some additional data, but in the care provision domain, you are more focused on what's actually used inside your health record systems.
Sure. Ruud also had another question, but I see he's online, so maybe he wants to ask his question about consent registers himself.
Yeah, well, actually, and I have one additional question about the answer, Birger, that you just. So do I understand that you have in Germany for the platform 2 instances? One is focused on healthcare, and one is more focused on research.
Yes. So this is the basic idea that there are different flavors of the platform, and we are implementing 2 platforms inside the hospital information system of Hannover Medical School. Yeah.
Okay. Cool. Yeah.
And the other question on consent registers, would you like to ask it yourself?
Yeah. Well, actually, it's straightforward. Actually, we're just wondering. I don't know all the details about the German healthcare system, so I was wondering if you have some generic services like patient consent services, maybe a master patient index, or some of these more generic services that you have from your overall system that you can use within the platform, or do you have all these functionalities as part of the platform?
I would say everything is part of the platform, so there's nothing on a national level that would help us. So as shown, there are some services that sit between the university hospitals, but it's quite a thin layer. So for example, we have one component for privacy preserving record linkage, so using some Bloom filters and some demographics to be able to identify patients across the different repositories in the university hospitals. And then there's one FHIR terminology service hosted by University of Cologne that is getting federated into some local instances, but this is just an option. But this is, I think, basically it regarding centralized components for HiMAT.
Okay. Michael van der Sel had a couple of questions as well. Perhaps he wants to ask them himself. I don't think so.
Yeah, sure. I can.
Yeah, sure. Yeah, I can see you. I'm sorry. That's sometimes the problem if you have multiple pages. Ah, yeah, there you are.
Yeah, I'm here. No, I was wondering how you keep track of all the data that is sent out. So you described that there were ways to have a selection of the data that you then give to others, etc. But how do you keep track of all those things you give to others?
Okay, so you're talking about the use case where we would allow data to be sent to a different hospital. Okay, so basically, it's only working on the result sets. So we are not talking about fragments of the electronic health record in this sense. So it's more about that you define your select criteria. So based on these AQL queries. And then if you are, I mean, it's a difficult process because you have to have use an access committee allowing your specific data question. Then it needs to be distributed in the network. And of course, then there is what I just briefly mentioned, a so-called data sharing framework, which is basically a distributed business process engine, which tracks your data request in the different sites. So this means that everything that you are asking for is audit trailed. And of course, the data is only meant to be used for the purpose of research. So it's not, let's say, getting mixed into your local hospital information system. So it's not really in data exchange in the sense that IHE would do in a network. We are more interested in their research result sets.
Okay, yeah, thank you. Yeah, well, it makes a lot of sense, but I was just wondering how that would work for you.
Yeah, good question, thanks.
Actually, maybe a follow-up question on the remark of Michael, because my interpretation of that question was also to understand to what level do you actually store data from the participants, so from the university hospitals in a central repository, or at least bring it together in the data hubs which are locally federated in the university hospitals. So do you also consume data from other data sources in the region, from other healthcare providers to make a longitudinal record for the patient and bring that actually together, the data in a platform? Or is it really federated to the level that you say, if we need it, we query the data, and then it's basically brought together as an overall actual patient record view at that point in time?
Mm-hmm. Yeah, inside HiMAT, it's truly federated. In the COVID-19 platform, we have this additional centralized platform, which has more like the character of a clinical registry on a federal, sorry, on a national level.
So for the clinical data that you use in the HiMAT platform, that's really federated. But for the COVID use case, you have these, you said fire stores, and then the data is actually consumed batch-wise and then populated into a central repository.
Yeah, it's basically pushed then into a centralized repository. So like maybe your regional cancer registry, if you have one, for example, in Lower Saxony, there's one where we live. So collecting cancer data for 7 million patients.
But it's probably
and it is centralized and it's being actively sent by the different hospitals. Yeah.
But it's probably de-identified, so not really traceable to an individual person.
Yes, so there's an de-identification process happening. And yeah, I think this was mainly a decision regarding time to market, so that we are, let's say, able to have an answer for COVID-19 in a short amount of time, because I mean, this distributed query thing is still something that needs to evolve and that needs to be improved for sure. And so we thought that a centralized platform can be a nice complementary approach to serve us in the short term, maybe also in the midterm.
Okay, I'll go to some of the other questions, if you don't mind, Ruud.
Yeah, sure.
Lasse Makela, I think, probably pronounced wrong. Are searches involving many patients or just one per what? I don't know, because there's a dot there. And if many patients, how strained is the database? Do you see any slowness, or is the patient data shifted to another server where all the searches are made?
So it depends on the use case. So we are having somewhat enterprise data warehouse approach, where you have all the data in a semantically annotated format. And if you need really high performance on a specific topic, then you would build a data mart. So I think there's not one answer, because openEHR implementations are all different. So when there's some answer for the beta platform, I think for Airbase doesn't necessarily apply. So I can just say for Airbase, it's basically a Postgres database, and you can do sharding and you can index the data as you like. So it's more like a matter of optimization for specific use cases, but you can do this because you basically control what's in the Postgres database.
I can add something for this mix, because we at some places we need some queries for querying a lot of patients, and this mix, that is based on the Better by Marant platform, yeah, indeed has some problems sometimes, because we are searching for so many patients. However, we think it's a configuration issue. So I think we have to test it with Airbase, for example, but we don't think this is a general problem with AQL or openEHR. It's just, yeah, an implementation configuration thing.
All right. Just a couple of short questions, I guess. Maybe also some short answers here. Will the COVID-19 application also be available to other countries?
As soon as we consented on the licensing thing, yes, I think so.
Okay. To Birger, does the platform include any proprietary components?
Yes, quite a lot, but all based on open standards.
Very good. Yeah, better is a proprietary component, but based on an openEHR standard, for instance. Yeah.
Yeah, I mean, especially the IHE XDS stack, it's all proprietary because there's no decent open source IHE stack implementation. So. All
right, sure. Using Fire and openEHR, what are your experiences and what do you need in the future?
Both.
Both. That's a really short answer. And to your experiences?
I can elaborate on that. I mean, what we gain through AQL is quite a lot, I would say. So this allows us to build applications quite quickly. And it's you really see the difference that openEHR is optimized for application building. So we have been able to set up what you've been seeing, this proof of concept, within 6 weeks using Airbase, which was not that major at this time. So I think this really shows. But on the other hand, when you need to connect to different silos, then openEHR might not be the best solution. Then you need Fire for the black box. But then, of course, it's not as broad and deep regarding the clinical models, I would say. And also for front-end developers, I think Fire has its limitations. It's really not good for people who would like to build applications. So that's the more comprehensive but still short answer.
Yeah, and then there is quite a technical question, or technical microbiology question, I think, from Eric Zundval. He's asking, are you also making microbiology models, templates, archetypes for NGS? I don't know where that stands for. Gene sequencing. Oh, he says it actually. Based tests.
Yeah, indeed we do. We want to expand the current microbiology template with more slots to include pathogen details, and we will include the results on the NGS things. However, we won't include a whole NGS sequence results, but some aggregated data. But we are currently developing models for that.
Very good. Perhaps, Antje, you can have a look at Dr. Suda's question in the chat, because we're running out of time. I think we could have another afternoon with questions, I suppose. But I think everybody, at least it was a very interesting topic, and very good to see how you can use all these components together and create something that's both for research and real life applications really interesting. And I hope to see a lot of work from you coming to the international platform and looking at that. So thank you for your presentations.